should go. Yeah.
So my primary purpose, okay, let's uh, in your last email about this conversation, you talked about SH can be neither destroyed nor created, right?
Mm-hmm.
So, okay, see, I mainly have two purposes. One is to uh, clarify the meaning of uh, can neither be created nor be destroyed.
Mm-hmm.
Uh, Try and understand uh, why you want to talk about what you want to talk about, the significance of uh, such a postulation, and also the assumptions that go behind postulating something as neither being creatable, for the want of a better word, or destructible.
Okay. There is a slight problem in the use of the word create and destroy because these words imply creator and destroyer. Okay.
Yes.
So that kind of makes us think about Brahma as a creator, Vishnu as a sustainer, and Shiva as a destroyer. This is the kind of classic paradigm that we have. If you
Mm,
remove the deities from this discourse, there
mm,
is no creation. The world was not created. The world came to exist.
mm,
Life was not created. Life came to exist. So we should, to be
mm,
very precise, we should be saying uh, the transition from non-existence to existence, uh,
mm,
coming into being, and the transition from existence to non-existence, which is
mm,
something that exists and it becomes not non-existing. So existence, the transition, the processes that lead for something to come into existence, and the process by which it ceases to exist. Now, that is the
mm,
word that Darwin used, origin
mm,
of the species, and the meaning was species coming to exist,
mm,
not the creation of species, but species coming to exist. Darwin did not, say anything about extinction except implicitly that under certain conditions, uh, you know, you can interpret Darwin as saying, uh, if they don't if they don't reproduce, they'll cease to exist. But
mm,
he did not construct a theory of extinction.
mm.
But that doesn't matter. I'm saying uh, origin and extinction, or birth and death, etc. They're the same concepts. Birth applies to
Okay.
individuals. Origin and extinction applies to larger taxa, species, or higher order mammals, and so on. When did mammals
Okay.
come to exist? When did insects come to exist, and so on? Yeah. So
Okay.
that
So
idea
let
is,
me,
yeah. So let me
yeah,
complete
please.
this. That idea is what Dalton was using in his postulate, fifth postulate. Atoms are neither created nor uh, destroyed. What he should have
Mm,
said was, atoms do not come to exist. They have always existed. They are eternal and they would never cease to exist. So there's a
mm,
total permanence and eternality to atoms. That idea of the drive to look for unchanging permanence.
mm,
I use the word unchanging because origin involves a change from non-existence to existence, but it could also have
mm,
uh, non-abrupt or non-discrete changes, such as, for example, increase in temperature.
mm,
Increase in temperature is, quantitative change. So whether it is a
mm,
quantitative change or qualitative change, people have looked for, things which do not change.
mm,
And in physics, they're called conservation laws. What is conserved is such and such.
mm. Okay.
So it was the widespread appeal to that idea in many disciplines, including, for
Mm,
example, chemistry. In chemistry, the conservation is in the change of structure. But when the structure of molecule changes, then a
mm,
total number of atoms in the input and the total number of atoms in the output should remain the same. And
mm,
that's the idea of balancing equations.
mm, mm,
So this was the aspect that I was kind of pointing to when I said X cannot be created or destroyed. It's also there in, Brahman, for example, or God. If you ask the question, okay, Brahma created the world, who created Brahma?
mm,
And you keep asking that question, there has to be a creator who is not created.
mm,
And that was Aristotle's idea of God,
mm,
a changeless change maker. God himself doesn't change, but God makes changes
mm,
or cause. God is not caused by anything, but God causes other things.
mm. So when you say, okay, so you're not talking about the origin of something. You are talking about eternal existence.
Yeah, not even that. I'm talking about the idea of
Mm,
eternality in the human
mm,
mind, both in the popular mind and the academic mind. It manifests itself in so many different ways.
mm,
No, I don't
the
know if
exam-
anything is eternal or not.
mm,
But the idea that there exist eternal things, unchanging things, and we must look for them is part of the human endeavor, human search for knowledge.
mm.
And that the answer given in Buddhism is that there is no
Mm,
such thing. Impermanence is a central theme in Buddhist thinking,
mm,
as distinct from Brahman, which has the property of eternality or whatever, timelessness, whatever you call it.
mm.
So Buddhism and Vedanta, in this sense, are presenting opposite positions, like Heraclitus and Plato.
Mm. Now, you've given an example in chemistry of atoms, right?
Hmm.
And when atoms are neither created nor destroyed, you get conservation of mass. So, what?
You can get conservation of mass even without that assumption. Law of
Oh,
conservation of mass, mind you, existed. That idea existed before Dalton.
oh, yes.
Law of conservation of
So,
mass is stated in terms of the continuous, quantitative.
mm,
They
mm,
weighed the mass before the chemical change and after the chemical change and established it's the same. That's a that's a continuous change.
mm,
And Dalton pointed out you can explain that, the continuous law of preservation of mass, by assuming atoms with
yes.
fixed masses.
Mm,
That was the genius
mm,
of Dalton's move,
mm,
providing an explanation for the previous laws.
mm. Okay. So, Okay, it's not the concept of atoms, but atoms themselves that have uh, an eternal existence.
That is what Dalton said. And I'm interested
Mm.
in the idea of
Mm.
preservation of atoms.
Okay,
Yeah, I'm
so
shifting
this
from,
notion, yeah, so
because it
this
turned out that
notion,
it turned out that Dalton's
Mm.
claim that atoms always exist has that atoms can be destroyed and atoms can be created. He did not know at that
Mm.
time. So that was a false idea, but I'm not interested in the truth or falsity of his ideas, but the underlying concept behind the idea.
So outside Dalton, where in science do you find this notion of eternality?
Oh, all the conservation laws are of that type,
Hmm.
right? And going beyond conservation, uh, the idea of perfect symmetry is built into geometric transformations. In fact, all kinds of transformations. This is where,
Okay.
in fact, in our Sunday conversation, it moved from the idea of created, destroyed to the idea of symmetry and symmetry breaking. That was a little bit of a stretch, and it is possible that many people didn't get that leap from, you know, uh, the the permanence idea to the idea of symmetry. Permanence is a matter of time. Symmetry, on
Mm.
the other hand, it need not be a matter of time. But let me elucidate that. The symmetry is generally defined as that which remains unchanged in a change. Change happens, but there is something that remains unchanged. Notice that is preservation.
Mm.
Okay? I'm shifting from uh, created, destroyed, origin, extinction to what is preserved. And that's a conservation law. Now, the best example for understanding this is to look at geometric transformations. So if you take an equilateral triangle and rotate it,
Mm.
there are three configurations where you cannot tell whether change has taken place or not. Three orientations.
Mm.
So mathematicians would say that equilateral triangles have a rotational symmetry, that which is unchanged, of three. But what about a square? A square can be rotated in four states. So squares have rotational symmetry of 4. What about a regular pentagon? It has a rotational symmetry of 5. Regular hexagon, rotational symmetry of 6. And by extending further, what about circle? Circles have no angles. And even if it doesn't matter how much you change, it still looks the same. So the idea is that circles have perfect symmetry.
Mm.
And the Greeks wanted everything in circles. God created a perfect world, so God could not have created, anything other than circles. That was a perfect thing. And this idea was so strong in Kepler that he couldn't come to bear the idea that planets move in elliptical orbits. The data told him, the calculations told him, he has to assume that planets move in elliptical orbits. But ellipse is not a, perfect shape.
Mm.
Finally, he overcame that idea of perfect shapes and said elliptical orbit. So there was a conflict between his ideology of God not creating perfect shapes and his scientific temper, which said, no, you have to conclude that it is an ellipse. So to understand Kepler's dilemma, you need to understand the earlier idea of perfect symmetry of circles. If you do that, then you understand symmetry breaking. If a circle changes to, let us say, a polygon with straight lines, then polygons have finite symmetry. no matter how many. But at the same time, there is something that polygons share, regular polygons share with circles. What they share is symmetry. And the breaking part of it is the circular path becoming a straight line, curved path becoming a straight line. That is breaking. And now you find that this makes sense in evolution. What is it that is conserved from the evolution from bacteria to humans? If you look at the evolutionary history, you find every evolutionary change is an act of symmetry breaking. This is how mathematicians and physicists would see evolutionary history, as symmetry breaking.
Can you elucidate?
Symmetry breaking is the emergence of an asymmetry where symmetry existed, so that the symmetry is now less. So imagine, for example, let's imagine Big Bang cosmology. At the very beginning, the entire world, every part of the world looked exactly the same. There was no distinction. And then that's a kind of plasma, actually pre-plasma state, the Brahman state of the world. And then comes these fundamental particles. So now there is a distinction between fundamental particles and and things where there are no particles. That's an emergence of a distinction. Now, fundamental particles come together to form nuclei. That's also an act of symmetry breaking. Within nuclei, there is a structure, and the nuclei combine to form electrons. Atoms are formed. Something that did not exist prior to that comes to exist. So nuclei, fundamental particles come to exist. Nuclei come to exist. Atoms comes to exist. So you could say this is the atomic period, molecular period, and so on. Those periods kind of continue. And then not only atoms and inorganic molecules, but biomolecules come to exist. When the biomolecules come to exist, you could say that's the beginning of the life period. Or you could say life comes to exist only when cells come to exist. That is up to you. It doesn't matter. So you could say, without referring to life, you could say biomolecular period and cell period. And cell period first was unicellular period. And then you have multicellular entities. And so on and so on. You can say vertebrate period. You can say mammal period, primate period, human period. So at all these steps, there is symmetry breaking in the sense of distinctions come to exist where they did not earlier.
Okay. Now, see, when this is seen as emergence, I'm able to get it.
Yeah.
Okay.
Emergence is symmetry breaking.
Right.
Yeah.
So, see, I'm finding it hard. Okay, I get what you're saying. So when, I don't know, when before fundamental particles existed, there was a certain state in the universe, right? And there was a certain homogeneity, right? The emergence of fundamental particles kind of disrupted that homogeneity.
Yeah.
Right? In that primordial state, I understand the disruption of that homogeneity as symmetry breaking. But once fundamental particles emerged, right? Two things exist. I don't know. You have to tell me, because I don't understand cosmology, origin, this thing and that. So after fundamental particles, emerged, did two things exist or did only one thing exist? So when I say two thing or one thing, what
Yeah.
do I mean? Did the fundamental particles
Hmm.
and that from which the fundamental particles emerged
Huh.
exist, or did only the fundamental particles exist?
That's an important question and a good question. Let me uh, let me use a metaphor or a visual image.
Mm,
Assume, for example, of course, at that stage there was no color. Color
mm,
comes much later. In fact, color is a human experience, but let's still assume
yeah,
that the entire universe was blue in color. So no
mm,
matter where you looked, everything is blue. So
mm,
that state, there are no distinctions.
mm,
Now assume that fundamental particles are red in color. So
mm,
there is a space in which you have the blue space, and then there are these objects called red.
mm,
Okay, so there's a distinction between red and blue. So
mm.
there was only blue first, and then blue and red, the distinction between blue and red emerges.
Okay,
And then
fine.
some of these reds come together to form this slightly larger thing called green. But
Yeah, yeah,
fundamental
we'll come to
particles
that.
remain.
We'll come to that. We'll come to
Yeah.
that. Um,
So
so,
let me complete. Emergence of
okay, okay.
multicellular creatures does
Mm,
not mean that unicellular creatures become extinct. They both coexist.
mm,
Something new comes up. But that new coming up creates a distinction which did not exist earlier. There was no distinction between unicellular and multicellular earlier. Now there is a distinction. So it's an emergence of distinctions. Unless
mm.
like dinosaurs becoming extinct, some distinction disappears.
Mm. Okay. Um, so are you saying it's the emergence of distinctions
Mm,
along with the preservation of what existed prior to those distinctions emerging?
yeah, that is
All right.
what remains. What remains unchanged is symmetry.
Okay.
Yeah.
Uh, so let me also ask this question. Um, when you say the preservation of what existed uh, prior to the emergence of that distinction,
Mm.
uh, one second, I'm trying to frame this. Okay. See, whatever existed prior, let's say, uh, w- Y emerged from X.
Mm.
Okay. Now, there was a world in which there was only X.
Mm.
There was a, okay, then at some point, the world turned into X and Y,
Yeah.
right? So, my question here is, okay, so when we say X exists and Y exists,
Mm.
uh, after the emergence of Y, does X exist as a part of Y, as that which is a part of the compositionality of Y, or does X have an independent existence apart from Y?
Ah.
And the question that I'm asking, okay, uh,
Yeah.
see, because I think this is important to understand symmetry breaking,
Yeah.
uh, because what existed, okay, um, I don't know if the word, see, they say it does not make sense to, physicists would say it doesn't make sense to ask the question, what happened before Big Bang, because time started with Big Bang.
Mm.
Uh, okay. Uh, so rather than using the word Big Bang,
Mm-hmm.
okay, so rather than using the word before,
Mm.
right? Uh, So whatever Big Bang emerged from,
Hmm.
right?
Hmm.
Uh, does that exist now?
Well, you see, to answer the question, does that exist now? We have to understand at least some aspects of that state.
Okay.
What we have right now is a speculation without understanding what it is,
Hmm.
right? So these are questions for which we don't really have an answer. We are we are approaching the limits of our understanding, and it is possible that we'll never understand.
Okay. So in that case,
Uh,
how can you call that symmetry breaking is my question. If you are unsure,
uh,
okay.
no,
If
no.
you are unsure
There are two
right now
questions.
into, hmm,
There are two questions. Physicists currently assume, cosmologists currently assume that
hmm,
at the point of the Big Bang, let's say a few microseconds after that thing, there was perfect symmetry. And if you could say something like, at that point, what existed? The world was just energy and points, point area, let's something like that. That's one way of understanding it. But what existed prior to that is not an answerable question. Or what did it emerge from is not an answerable question. You could say God, who knows? That is the point where you can postulate God. The world emerged from God. I'm using the word God now in a completely
hmm,
unfamiliar sense. You could say
hmm,
Brahman. Okay, you could either say Brahman is energy of that undifferentiated energy, or you could say Brahman doesn't even have energy. Energy came out of Brahman. These are all, speculations, incredible speculations, but these are good speculations to, to spell out. um,
okay. So what you're saying is first energy existed and uh, then came fundamental particles
yeah,
and then atoms and then
yeah.
molecules and so on.
And in that
So,
history, there are different
hmm,
kinds of energies also.
hmm,
Consider, for example, electrical energy versus magnetic energy.
hmm.
Did magnetic energy exist at that time? Did kinetic energy exist? Did potential energy exist? And then the energy begins to diversify into many different kinds of energies, and matter also diversifies. And in a certain sense, the evolution of the world is an interplay between energy and matter. In Sankhya, you could say it is the interplay between Purusha and Prakriti.
Mm. Okay, not going into Sankhya. Okay.
Okay.
Uh, um, but okay. So now when we look at cosmological evolution this way,
Hmm.
okay, let's get back to symmetry breaking,
Yeah. Well,
right?
relevant one minor point.
Mm,
Um, I have been talking till now about the emergence of units,
mm,
units like electrons, atoms, molecules,
mm,
etc. These are units.
mm,
Now, there are also
mm,
distinctions also involve categories of units,
mm,
not just fundamental particles, but also different kinds of fundamental particles,
mm,
not just atoms, but different kinds of atoms. Now, if you
mm,
extend your question to that, okay, uh, at some point in the history of the human species, different languages, okay, the unit
mm,
called language comes to exist, and then different languages come to exist. So, for example, there's a language called Malayalam, there's a language called Tamil.
mm,
Assume for the moment that these ideas are, you know, ideas are defendable,
mm,
but you have to have a theory of categories to say this is Tamil and that is Malayalam. Okay, now linguists say that Tamil and Malayalam both came from proto language, when the
yeah.
distinction between Tamil and Malayalam did not exist.
mm,
And the distinction between that proto-language and Kannada and Telugu did not exist. So there was Proto-Dravidian.
mm.
Okay. Now ask the question, was Proto-Dravidian Tamil, Malayalam, Kannada, or Telugu? That doesn't make sense.
Mm.
Okay. So the question, which was the origin of which? Was it Malayalam that came from Tamil or Tamil that came from Malayalam? Is a meaningless question for linguists.
Mm. Okay.
What exists was a proto-form where these distinctions did not exist. And then the distinctions emerged.
Mm.
So should we use the word Tamil for that proto-form? Or should we use Telugu for that proto-form? That's an arbitrary choice.
Mm. Okay. Mm, fair enough. But I'm going back to symmetry breaking.
Sure, yeah.
Okay. Now, let's take there was all energy, let's say after Big Bang, there was energy, and then there were fundamental particles. Okay. Uh, okay, you take that state, okay, as a
Mm,
snapshot where you have only energy and fundamental particles,
mm,
right? Now, this is not a world, this is not a universe where there is homogeneity. There is
mm,
variability. You can say, right? Because there are two. You have energy and you have fundamental particles. Now, let us say in the third state or in the third phase, you have energy, you have fundamental particles, and you have atoms, right? Now, uh, between the second state and the third state, okay.
mm,
So,
mm.
my question is, what was the symmetry in state two that quote unquote broke in state three?
Mm. Okay, let me see if this works. All fundamental particles were identical. Fundamental particles, there was no distinction between different fundamental particles. They were all the same. And then comes different kinds of different categories of fundamental particles, like electrons, positrons, photons, and so on. Photons do not have mass, but they have energy. Photons don't have charge, but electrons have charge and mass.
Wait. Okay. Okay. So you're talking about the symmetry within fundamental particles.
Yeah, or the symmetry of fundamental particles with no distinction. Two, the broken symmetry
Ah,
where fundamental particles, different kinds of fundamental particles are distinct. Emergence of distinction is a good way of thinking about it. We have to use slightly different words to get to the understanding.
okay. Right. Yeah. Okay. So, okay. So I was stuck in a place where, uh, um, see, the moment fundamental particle emerged, see, this thing was the moment
Mm.
fundamental particles emerged, the moment you have two, it's not the same anymore. Then what symmetry are you talking about? Now I understand. See, what I was taking to be symmetry of the whole universe, you are talking about symmetry of a certain aspect of universe
Yeah,
that kind of broke. Okay,
yeah.
right. Okay, fine.
So
This
again,
I'm
the
able to get.
Indian philosophy also helps. You and I are manifestations of Brahman,
Hmm,
right? But there is still the distinction between you and me.
hmm,
And human the human species is a manifestation of Brahman. At the level of human species, the two of us are not distinct.
Mm.
We're both human. That's a symmetry.
Mm.
But when you compare us with chimpanzees, there is a distinction. So the distinction between chimpanzee and human is also, a distinction which did not exist prior to some stage in evolutionary history. All of us are manifestations of Brahman, but at the same time, there are different manifestations. So the question, which is the true reality at this stage? Well, the true reality is both Brahmanness and these particulars. They coexist.
Mm.
That is the idea of manifestation. When you say that diamond and coal and graphite are all manifestations of carbon atoms or carbon molecules, let's say. So that does not mean that the only reality is that of carbon molecules, but also there is a reality of graphite versus diamond.
Mm. Okay. Mm. Now let's put symmetry breaking and compositionality together. Okay.
Mm.
Big Bang happened and there was this energy, right? Now, and then there came fundamental particles,
Mm.
right? For Y to emerge from X,
Mm.
okay? If you say Y has emerged from X, in some sense, Y has a certain independence from X.
Well, one could say that, provided you clarify the notion of independence. Yeah.
Uh, See,
You mean causal independence?
not exactly. What do you mean by causal independence?
Um, when you say X is independent of Y, it can be the case that X caused Y, but not the other way around.
Okay.
Unidirectional causation. But if it is
Okay.
bidirectional causation, then they are mutually dependent.
Fair enough. Okay. So I mean the first, unidirectional causation.
Mm.
Okay. Uh, okay. So when I say has an independent existence, I'm not even going into the causal relation.
Mm.
If a cognizer is able to see both X and Y as distinct,
Huh.
okay, that's what I mean by having an independent existence.
Huh.
Okay.
Now
Now,
comes a difficult problem,
uh,
because if you translate the language from the language of change, when symmetry is that which remains unchanged in a
mm,
change. That is the way I define symmetry in a procedural language, which crucially involves
mm,
time. Okay.
mm,
Remove time from that statement. What is symmetry? If you remove time from symmetry, then it's a matter of similarity and difference. Take the two of us. What is it that is symmetric in us? That we are both humans is symmetry. But there is no time element here. It is similarity. We are similar in the sense, or sameness. That we are both human is sameness. But
mm.
we have other, your hair is black, my hair is gray. That's a difference. So similarity and difference So now you can say symmetry is the existence of similarity in difference. But here's a glitch. Similarity cannot exist without difference, and difference cannot exist without similarity. So without causality, one cannot exist without the other. They're two sides of the same coin.
Okay, so in that case, let's come back to this thing. Okay, to wrap my mind around something, I need that the example to be fixed, because that makes things easy for me. At least in the initial stages. Let's come back to Big Bang. You had energy, and and then from the energy came fundamental particle. Okay, we are not even going into different kinds of fundamental particles and so on. Okay, let's talk about the second thing that emerged after energy. Now, if you, I don't know if it's a theoretical physics question, it probably is, but if you take away all the energy, would the fundamental particles cease to exist?
So let me ask this particular question. Would electrons exist if electrons did not have negative charge? Would positrons exist if positrons did not have positive charge? Would photons exist without some form of energy?
No, because photons are a kind of energy.
Yeah.
Okay, but that presupposes, then it's a question of, um, then it's also, then, okay, rather than asserting, let me ask you the question. Then is it a question of compositionality? Because fundamental particles are made of energy.
Yeah, but they don't have compositionality. You cannot say electron is made up of. Unlike atom, you can say atoms are composed of electrons and nuclei. Nucleus is made up of such and such. The water molecule is made up of 2 atoms of hydrogen and 1 atom of oxygen. These are matters of compositionality. Now structure begins to emerge. This is where the other concept emerges, atomicity. Atomicity means there is no internal structure. Now, Dalton assumed that what he called atoms are atomic. It turned out that atoms are not atomic. Fundamental particles are atomic. Now, are we sure that fundamental particles, what we call fundamental particles now, are atomic? Maybe 20 years from now, people will discover they have an internal structure that we are not aware of. But right now, there is no evidence to assume that. So structure emerges in the course of the evolutionary history of the universe. And emergence of structure, not emergence of distinctions, but emergence of structure is an important aspect of our investigation. So Santa Fe Institute of Complexity investigates that.
Let me come back to the example. Fundamental particles and energy. As of now, okay, going by a current understanding, there's no internal structure to fundamental particles. Yes?
Yeah, that is the current assumption.
Yes.
Yeah.
But fundamental particles emerged from that state of raw primordial energy. Right? Which means, as per our current understanding, even though fundamental particles originated from energy.
Can you repeat that because you froze for a few seconds?
I'm not sure if I froze or if I was thinking.
Oh, okay.
That's okay.
Yeah.
I'll repeat it anyway.
Yeah.
Okay, so fundamental particles don't have an internal structure, so we cannot talk about their compositionality as of now, right?
Yeah. Hmm.
But we also agree that fundamental particles must have emerged from that energy,
Yeah.
right? Now, if that is the case, even though fundamental particles originated from energy, our current understanding is, as per our current understanding, they have an existence independent of energy.
The word, I'm a little worried about the word independent.
Mhm.
Are electrons independent of energy? Electrons have energy. Positrons have energy. Photons have energy.
Okay, so fundamental, like that. Okay, so you're saying fundamental particles have energy.
Yeah.
Okay. Uh, okay, then in order to understand, so something happened. One second more. So at the time of Big Bang, so the energy that existed, something must have happened to that energy that fundamental particles emerged, right?
Okay. Or rather,
Mm.
you call that an event. I mean, you're saying
Mhm.
that something happened and as a result, electrons emerged or fundamental particles
Mm.
emerged. A slightly
Mm.
different way of saying it is to say that emergence of fundamental particles is what you call
Mm.
something happening,
Mm. Okay.
not as a result.
Mm. Right. So now the question is, what triggers symmetry breaking in a state of perfect homogeneity?
Okay. This was a question that Ilya Prigozhin asked in his work on
Uh-huh.
self-organization. He
Mm.
points out that universe has the property of self-organization,
Mm.
and self-organization has various strategies. For example, it makes distinctions. It
Mm.
creates new units and creates categorical distinctions between units. And then what happens is it combines different categories to form a larger unit. Right? For example,
Mm.
let me use the word creates electrons, it creates positrons, charged particles, negatively charged, positively charged, and they all come together to create a
Mm.
nucleus.
Mm.
That merging is also part of the self-organization. Different categories
Mm.
of units come together to form a unit. So
Mm.
different atoms combine to form molecules. So that
Mm.
combination is also part of self-organization, and that there are many other aspects of self-organization that Prigozhin discusses, and we can see those things if you look at anything from the point of view of self-organization. A large number of things which we didn't see earlier, we are able to see. Now, Prigozhin asks, what is the cause of that self-organization?
Mm.
Why does universe have the property of self-organization?
Mm.
To change the metaphor somewhat or the terminology somewhat, I can ask, Brahman has a property of self-organization. Brahman is not Nirguna Brahman. It has the property of self-organization. And what
Mm.
causes that property? And Prigozhin says, I don't know. All I can say is that self-organization is part of the Leela of the universe. He uses Sanskrit word
Mm.
Leela. He says,
Now, see,
I don't have an answer.
this is okay. So now, the difficulty I have with that explanation is now I'm not talking about the Leela part.
Mm.
Okay. Let's talk about self-organization. So self-organization assumes that two distinct entities come together or merge or act in a way that a distinct entity is created with an internal structure,
Yeah.
right? But uh, how can you talk about self-organization in this sense
Mm.
in a state where there's perfect symmetry?
Ah,
You need to have
yeah,
distinct entities to come together for
yeah,
self-organization,
yeah,
right?
yeah,
You talked about electrons and positively
yeah.
charged particles coming together, or
Mm.
neutrally charged particles, all of
Yeah,
these fundamental particles coming together to form the atom.
yeah,
It is understandable
yeah,
because you are not talking about a universe, you're not talking about a universe in which there is homogeneity,
yeah.
right? So, so I don't think what Ilya Prigozhin, okay, what that person is talking about applies to a universe, uh, applies to that phase where the universe transitions from homogeneity to variability.
Yeah. So let me take a slightly different case to throw light on that question.
Mhm.
Uh, People discovered uh, palm seeds which were like 1,000 years, I don't know, 1,000 years old,
Mm,
and there was no metabolic activity inside the seed.
mm,
All right. If there is no metabolic activity, let me ask the question: was the palm seed alive? And when some water was poured, suddenly it metabolic activity started, and it grew into a whole palm after thousands of years of. So the question, was it alive at that time? You have to say, well, it had the potential for being alive, but it was not alive. And
yes.
David Bohm says something similar, that universe has implicate order. That is, it may not have order, but it has implicate order. It has
What does implicate order mean?
the
Uh,
potential for developing order.
Potential for developing order. Okay.
Yeah.
Mm,
So what Prigozhin meant was that self-organization is a property that implicate for creating structures, creating distinctions, and so on. But it was not at that time. It didn't have distinctions. It did not have structure. So structure formation is an important aspect of self-organization. How does structure come to exist? How does function come to exist? These were two important questions that Prigozhin asked:
mm.
structure and function.
Okay. We have only 5 minutes. I need to drop my daughter as well.
Uh-huh.
Okay.
Well,
So now, uh, so what advantages? Okay. So you can look at things as the emergence of distinctions. Okay. And you can look at this as the breaking of symmetry.
yeah.
Now, from my conversation, while you do not sideline emergence of distinctions, what you seem to be particularly excited about is symmetry breaking, right? So, between conceptualizing things as the emergence of distinctions and the breaking of symmetry,
Uh,
uh, does symmetry breaking, does looking at things as symmetry breaking have any advantage? Does it have any advantage?
it has advantage. The only advantage I can see is that it opens the mind of a researcher for looking at a problem. When you
Mhm,
do research,
mm.
this way of thinking, it's not a theory in the traditional sense, but it gives you a perspective such that questions that you wouldn't have asked otherwise become important for you. So autobiographically, until I bumped into Prigozhin, which was in 1983 or so,
Mm.
I was a hardcore Chomskyan. And when I read Prigozhin, the whole world collapsed. The Chomskyan world collapsed under my feet. And I had new questions, Prigozhinian questions for me. And I didn't know how to answer those questions. So here was a problem that I was faced with. I was capable of answering certain kinds of questions in the Chomskyan paradigm. I was very competent. I was a good researcher there. But now I was no longer interested in those questions. And the questions that I was interested in, I didn't have the competence to answer them. So it was, you might say, it was the dark night of my soul. I didn't know what to do. It took me several years to restructure my thinking, to start thinking of linguistics in terms of self-organization. And the results came out, I don't know, around 1990 or so. I don't exactly remember. Yeah. So there was a long period in which I couldn't do research. And was that valuable? Yes, I think so. But it is very difficult to help you experientially understand that. My autobiography. Into your bloodstream, you will see the world differently. You will ask different questions, you'll come up with different solutions. I cannot prove it to you, in other words.
Okay, Mo, this was useful.
Okay.
Thank you so much.
Yeah.
Bye.
Bye. Yeah.